Welcome back. So in this problem set here, we are going to be working again with topics that pertain to colligative properties. So in the first one, we have a problem that says arrange the following solutions in order of decreasing freezing point. And they give you several different solutions and the molarities of each solution. Now, one of the things that we have to do is we have to pay attention to the molality, but you also have to pay attention to the Van Hoff factor. Now, if you're not familiar with the Van Hoff factor, I'll just go ahead and give you kind of a simple rundown of it here. So, when you look at a solution, all right, when you talk about taking this compound here and dissolving into water, well, this compound is going to dissociate into a number of ions. Now, the number of ions are related to the formula itself and how many of the metal ions versus the anions there are. So in this example, you have 3 sodiums and 1 phosphate. So that will give you a Van Hoff factor of equal to 4. So the Van Hoff factor symbol is representative of I. And so I would be equal to 4. And so that will make a difference, because if you look at this, at the molality, it's 0.1 molal. And if you just base it off of the structure as Na3 it'd be just 0.1. But if you take consideration of the Van Hoff factor, then now it's 0.1 times 4, which is going to give you 0.4 molal. So that's what we're going to do, is we're going to go ahead and figure out what the delta T is for each of those. Now, we don't need to worry about KB or KF. In this case, KF. It doesn't matter because KF is a constant. It's not going to change. What will change to delta T are the molality and the Van Hoff factor. So that's what we want to pay attention to more. So we have 0.1 times 4, which gives me 0.4 for my delta T. And all these are based in water, aqueous. So when we do the final part, we will have to take consideration the freezing point of water. NaCl. Alright, so NaCl has 2 ions, so the Van Hoff factor for NaCl would be I is equal to 2. So we'd have 0.35 times 2, which gives me 0.7. The next part here is calcium chloride. There's two chlorines and 1 calcium. That gives me a Van Hoff factor of 3. So you have 0.2 times 3, which gives me 0.6. And then you have finally the C12, C2H12O6. Now this is an organic compound. Organic compounds have a Van Hoff factor of 1, unless there's an ion attached to it. Then it's different, but in this case here, there's no metal ions, so the Van Hoff factor is 1. So it's 0.15 times 1, which gives you 0.15. So now what we want to do is figure out the decreasing freezing point. So it's going to become highest to lowest freezing point, and that's going to be based off of the delta T. So the larger delta T, the smaller the freezing point will be. So the C2H12O6 is going to give you the largest freezing point here. In fact, it's going to be negative 0.15, and then you're going to have negative 0.4, and then you're going to have negative 0.6, and then you'll have negative 0.7. So NaCl is going to have the lowest freezing point, and then you're going to have CaCl2, and then you're going to have NaCl. Is that right? No. What is that? 0.4. Okay, I can barely read my hand. Like, there it is. So Na3PO4, and then C2H12O6 for the last one. So that's how it works. So this would be our final answer for this problem here. So it's all based around the Van Hoff factor and the molality of the compound. Now our next problem that we're going to work with here involves colligative properties. Let's just read it here. You got camphor and naphthalene, both molecular solids, and be used to make mothballs. Now if you don't know what a mothball is, go back to your grandparents' house, go to the closet. It has that really distinct smell, and that's naphthalene more than likely giving off the smell. So you have a 5.2 gram simple mothball is dissolved in 100 grams of ethanol. Resulting solution had a boiling point of 78.9 degrees Celsius, where the mothballs camphor and naphthalene. Now, we can't just simply look at it and answer the question. What we got to do is a little bit of math here. We got to figure out how many moles of substance that were present in this. So in order to do that, because we don't know the molar mass of mothballs, and we can't just assume anything here. So what we do here is let's figure out delta T. So we got delta T is equal to, all right, let's see here, 78.9 degrees Celsius. We're going to subtract that from 78.41 degrees Celsius. That gives me 0.49 degrees Celsius. And so that's going to be put here. And the equation is equal to I. Now I is 1 because it's organic. And plus we don't know what the density of the compound is anyhow. We have Kb, which is 1.22 degrees Celsius per molal. And then we're going to have the molality. So we don't know the compound, so the moles of solute is going to be our variable here, so we're going to put that on top. But what we do know is the mass of our solvent, which is 100 grams, and that's going to be 0.1000 kilograms. So now all we do now is basically some algebra. We're going to solve for moles of solute here. So I'm going to do that for me right now. So we got 0.49 divided by 1.22. Then we're going to multiply that by 0.1. And so the moles of solute is equal to 0.0406. Now, the next thing we do is, you might be saying, well, what's the next step? So if we look at the top here, we're given the mass of the sample, but we also are given the molar masses of the two compounds. So what we're going to do is we're going to figure out the molar mass of the unknown substance by taking the mass of the mothball, and we're going to divide it by the moles that we just calculated. Because in the end, the units for molar mass is grams per mole. So all we're doing is just taking the grams divided by moles. So take 5.2 divided by that answer. And what we end up with is 129 grams per mole. And sig figs is not necessarily important here. They are important, but we're not going to worry about them because all we're trying to do is figure out what the identity of the mothball is. So we're going to match this up. So the molar mass of this is 129 grams per mole. The molar mass of camphor is 152. So okay, it's close. Naphthalene is 128. So based off of that, our unknown is naphthalene. The mothball is composed of naphthalene. In fact, that's typically what it is composed of, is naphthalene. But these two problems are based around colligative properties. The first one was based around Van Hoff factor and the molality, and just arranging freezing points based off the delta T. The second problem is based around colligative properties, in this case the boiling point elevation. So, and that's how I knew to subtract the temperatures here, because it's talking about boiling point elevation versus freezing point depression. Boiling point goes up, freezing point goes down. Thanks for watching.